And hey guys, welcome to the final Excel report number 3. Let's get into it. Starting off with theoretical and empirical probabilities. Right. So we took the theoretical probability here, which simply put is the calculation of the likelihood of outcomes, while empirical probability is taking the results of experiment and showing the probabilities based on that. Empirical probabilities, there's no one right answer. It varies from experiment to experiment, while theoretical probabilities, they're purely theoretical. It's just the odds, the pure odds of it will happen. There's only one right answer for that. So here we had the probability that one of these numbers, the chart here, all the way to 12, I believe that means was an even number, I believe. And so we have all even numbers here. You see the probability of that 18 over 18, the odds against the same, obviously, so the probability is 18 over 36, which is 1/2, or 50%. Here's one that it's additive or multiple. I guess that's a multiplier of 3. So let's see, that is 6 out of 30. The inverse of that is 30 over 6, so the probability is going to be 17%. Prime numbers here, there's only 6 prime numbers. So that's what I was doing right there, 17%. This one is 33%, as there's 12 out of the 36. And the final one, multiplicative of 12, there's only, or just 12, I think. And so there's only 4 12s on the board. It's going to be 4 over 32, lower odds at only 11%. Then we took the dice rolls. So we rolled the dice twice. We found the sum over here, which is just adding the two together, or the multiplicative, or however you say that, which is basically timesing them together. We did it 6 times, 60, 600, and 6,000. Here you have the results up here. The sum of the two dice rolled together, you see as this is kind of scattered here. And really, but as you kind of go further, you see it, the chart normalizes out on the 11 bends, and slowly gets more like a bell-shaped curve, as it should. Same happens here, kind of random with the product, but it evens out to show that trajectory that you'd think it would show. So lesson that is, the more times the dice is rolled, basically it's the law of large numbers. Basically, the more times it's rolled, the more accurate the chart will be, the more better representation of the data the chart will be. All right, let's go to binomial experiments. I'll zoom in a little bit so we can both see it. Here you have the 4 conditions in which a binomial experiment satisfies. You have, or where it's a binomial experiment, a fixed number of trials. Each trial is independent of each other. There are only 2 outcomes, and the probability of each outcome remains constant from trial to trial. Here, you see the 2 formulas, and then that's how you put it into Excel. We use that a couple times, and then we have the letters. So we took the probability that if you guessed on all 10 of the quiz questions, you get 8 of them right, or 80%. And I believe what we came up with was 0.4%. All 3 of these formulas, agree on that. You see each formula has the formula up here, or shown right here, basically up here on Excel. So we used, obviously the easiest one was just binomial distribution. We have C28 right here, C31, C30, or not C30, C29, and then false. We did the same over here for the lottery, the ticket winning amount. This is how much you'd win. And this is if you won $0, you lost $5. You made your money back here, and then we look at the probability that this happens. And you see the probability gets more and more, less and less of a chance. You start at 76% chance of not winning any money. Keep going, and then this is the expected outcomes, which obviously the expected outcome is you're not going to make any money at 1.55 buyer's expected outcome. The seller's expected outcome is going to be the adverse of that, inverse. At $1.55 they'll make, and so if they sell 5 million tickets at $1.55, they'll make $7,750,000, which is a lot of money. Obviously, on both of these, the odds are not in your favor. Expected outcome is that you will not pass with the 80% on the quiz. Here, the expected outcome if you're a buyer is you're going to lose $1.55. We dug deeper into what the lottery was, and again on this chart just to show you my formulas. It's a sum of the percentage is just the sum of F40 and F all the way through F53, and then the expected outcome is just timesing the outcome and the percentage, I believe, to get your expected outcome. Okay, yeah, so we looked at the lottery. Arkansas's lottery, it's straight off the site, myarkansaslottery.com, gave the summary. Most of it is spent about 50% of it's spent on game prizes and commission, and the rest are spent on clearing, advertising, and then fees for facilities. Georgia showed a different picture, and if you look on the website, it was really interesting. They actually had a graph, and this site it was like this a peach graph because Georgia's state fruit is a peach, and it had the percentages on here, and then I got the rest from the amount from the website, but the prize of the players, and their slogan was "It's all about the players" or whatever. The slogan was, so the players like it said the amount of money, the 2 million, and then the players had like a huge slice of the pie. It was like 50% of the pie, but in reality they have 0%. They're not paying out a lot of money. A lot of it goes to education, commission, expenses. A vast amount of it goes to education. And the same with Ohio. Ohio kind of mimics Arkansas. A lot of it goes to prizes or profits, and then the rest just go to commissions and operations. Yeah, so interesting stuff. I thought that was a nice connection to the other Excels. All right, let's talk about interest rates and loans. Look at simple versus quarterly and compound. A simple interest rate means the interest rate is just based off the principal loan. So you're paying 6% more of the principal invested the entire time. So this line's going to stay linear. On quarterly or continuous compound, the interest compounds each month. So the first month you'll pay that $3,600 plus the 6% the first year. But then instead of paying the interest off of this, like the simple, you'll pay the interest off of what you paid last year. So then you see it's a little more. It gets bigger and bigger and bigger until, and like the line chart shows, the difference is pretty telling. So obviously it's better to have a simple interest rate. Chart shows that. See, you can see our formulas up here, right here, and then showed Excel helped us do that. And then we came down to buying a house. Say the house cost $120,000, 5% rate, which is a high rate for a house. You look at the monthly payments, the more you spread out the year, it's going to be less and less. And so we said and this was the interesting part, if you do extra payments, you can finish paying off your house a lot quicker in a month. It's about 40 months that you're saving on. It's a lot of years. and you're paying a lot less as well in interest. So you're paying less if you pay more in the short run. See the house payments here, they go up. The total goes up over time because you're paying more in interest. So it's better to pay it off as quickly as possible. A good life lesson. You see the monthly payment goes up, while the total paid goes down. The more you pay, the less you're totally paying. You see the interest goes down as well, and the months as well. And then we looked at subsidized and unsubsidized loans. Unsubsidized loans mean that you're basically paying for the interest. It's a compound interest as you're studying college, so those 4 years do count against you, while subsidized means that the government pays for that interest, basically waives it for you for the years that you're in college. So you want a subsidized loan. Your monthly payment is lower and you're paying less back. It's just a more affordable option. Let's go to population and samples. As of right now, or as of a day ago, the U.S. population is at 329 million. And you can see the split on the pie graph of the political affiliation. A lot of people are independent, the majority, but it's not a vast majority. 29% is Republican, 27% are Democrats, and 6% are unknown. We see the approval rates. Obviously, Republicans are going to have a higher approval rate of Trump. This approval rate probably has changed in the last 12 months, but independents leaning more toward disapproving, and Democrats leaning more towards disapproving as well. That's to be expected. We took a random 25 of voters, and then we stratified the sample of 0.002% of each category of voters, just to kind of see when you're looking at sample size. Obviously, 25 voters is not enough to get an accurate sample size of the voters and the leaning of America. That 0.002 is a better chance. And then volunteer, again, that wouldn't work, mainly because people who volunteer usually have a bias that introduces bias into your sample. And convenience is the same thing. It's not going to be a good way to avoid bias. Doing it based on convenience, you're not going to get an accurate representation of the graph or of the data and the people. And then we did the Army. This was really surprising. 1 million women are in the army, or 1 million people are in the armed forces. 30% of that is women, 7% is men. You can see the graphs here. More men in the Army, Navy, Marines, and Air Force. By far the Marines. Although I believe that's because the Marines have the least amount of serving members, so that difference is going to be exaggerated a little bit more because it has less people. When we took the probability that's a woman in the Air Force, Marines, and Navy, so a woman that's not in the Army, that's 29.4% because a lot of the women are in the Army. Probability that a woman or a man is in the Army, or that someone in the Army is a man, so yeah, 35% chance out of the total. You could run into a Navy, Marine, or Air Force. And then they're in the military in American, that's 0.04. So 0.04 of our population currently serves in the military. It's really impressive. Yeah, really inspirational stuff. Obviously, and this does a good job of actually, because you're actually getting the full sample size of the men and women in our military. Let's go on to graphing. This is really cool. I really enjoyed this. Just taking some random numbers and trying to make cool shapes. 3D graphing is a great way of showcasing the data in an interesting way and also an informative way. 3D graphing does something that 2D graphing doesn't do, which just shows depth, which again increases the comprehension of the data. You see it here as well, but it also can lie to you. For example, like this one, we're going to click on this one twice, just so I can move it on its axis. I need to 3D rotation. All right, so let's go back to 0%. If you look at it from 0%, it just looks like a straight line, or just a straight incline. Not until you rotate it do you actually see that there's another side to it, which is important. you need to see the other side. So the X and Y rotations are important with 3D graphing. Here, I just made the cool looking graph. Has this indentation. As you see, it went 1, 1, 1, 1. There's some 2s there in the middle to create the indentation, and then there's 3s. So it's really cool how you can kind of create shapes out of 3D graphing. Excel is really good at using that. Right. Let's go to personal finance. I said, so last time my 3 cities were Dallas, Tacoma, and Little Rock. I chose Tacoma. The house there was $313,600,000. Well, I'm not a millionaire quite yet. So we did the simple quarterly and continuous compound. Obviously, as we learned in the interest rates sheet, you'd rather pay just the simple interest. And to that as well, not only when you want to pay simple interest, but you also want to pay, if at all possible, just a 5-year. Although that's not sometimes feasible for people. 5 years, that's $5,000 in monthly payments. Not most people can't afford that. So maybe a more affordable option would be around 20 years. You're going to pay a lot less, couple thousand less, and your monthly payment is only $1,600. Still a lot, but it's not that big of a difference from $300 a month or $200 a month, $1,100 a month. So again, you see the total amount that I'm paying gets less and less and less as the monthly payments go up. As a total, see, the total goes down as the years go down as well. So 5 years has the lowest total. The interest is lower as well. While your annual payment is going to be higher, you're getting, in the long run, you're saving money. And then we change the nutrition around because I'm paying a monthly payment pretty high at about 20 years. Obviously, skipping meals, saving money, but eating more healthy. So, and the reason I did that, so there's, compared to the other one, there's more good fats, improved oils, vegetables, more nuts and flour, more pasture-raised dairy and fruits, less seafood or resistant starches. That coincides with the amount of week I up to working more at 45 hours a week to make more money to pay off that. Less time for gaming or Netflix, more time for friends because I have a house to host. But not only that, yard work and chores are going to go up substantially, and family as well. When you have a house, the responsibilities come along with it. So you see sleeping and work have over 50% of the pie, 50% of my time. Friends, eating, chores, yard work have bigger slices than they did last time. All right, that's my Excel. I had a great time doing these and excited to be done. All right, thanks, guys.